There is a wide diversity in living organisms in our biosphere. Okay? There is a wide diversity of living organisms in our biosphere. There is a wide diversity of living organisms in our biosphere. There is a wide diversity in living organisms in our biosphere. Okay, there is a wide diversity in living organisms in our biosphere. There is a wide diversity. There is a wide diversity in living organisms in our biosphere. There is a wide diversity in living organisms of our biosphere. There is a wide diversity in living organisms in our biosphere. There is a wide diversity in living organism in our biosphere. There is a wide diversity. There is a wide diversity in living organism in our biosphere. There is a wide diversity. There is a wide diversity in living organism in our biosphere. Now, as a question that arises in our minds is that are all living organisms made of same chemical, that is elements and compounds? You have learned in chemistry how elemental analysis is performed. Elemental analysis. First, elemental analysis is performed. If we perform such an analysis on plant tissue, animal tissue, or microbial paste, we obtain a list of elements like carbon, hydrogen, oxygen, several others, and the respective content per unit mass of a living tissue. If same analysis is performed on a piece of earth crust as an example of non-living matter, we would obtain a similar list. What are the difference between the two lists? In absolute term, no such difference could be made out. All the elements present in the sample of earth crust are also present in the sample of living tissue. However, a closer examination reveals that relative abundance of carbon and hydrogen is in living organism with respect to other elements is higher in any living organism than in earth crust. First was elemental analysis. Elemental analysis is found to whether finds element carbon heavy whether. Next was how to analyze chemical composition. Chemical composition. When we continue asking in the same analysis of chemical composition, primary, secondary moleculars and biomolecules. First, there is a wide diversity in living organisms in our biosphere. Now the question that arises in our mind is, are all living organisms made of same chemical, that is elements and compounds? You have learned in chemistry how elemental analysis is performed. If we perform such an analysis on plant tissue, animal tissue, or microbial waste, we obtain a list of elements like carbon, hydrogen, oxygen, and several others, and their respective content per unit mass of a living tissue. If the same analysis is performed on a piece of earth crust as an example of non-living matter, we obtain a similar list. What are the difference between two lists? In absolute term, no such difference could be made out. All the elements present in the sample of earth crust are also present in the sample of living tissue. However, a closer examination reveals that relative abundance of carbon and hydrogen is more in living organism than in earth crust. How to analyze chemical composition? We can continue asking in the same way, what type of organic compounds are found in living organisms? First, key elements for that episode organic compound. How does go find the answer? To get answer, one has to perform chemical analysis. First, we will say elemental to find the element. Next, we will say chemical analysis. We can take any living tissue, a vegetable, or a piece of liver, etc., and try it in trichloroacetic acid. Trichloroacetic acid, Cl3CCOOH. Using a mortar and a pestle, we obtain a thick slurry. If we strain through the sluice, we obtain two parts. Eta hoise filtrate, eta hoise retented. Retented is inorganic, filtrate is acid soluble. Filtrate is acid soluble, retented is acid soluble. Etu hoise all the organic, inorganic, technically the acid soluble pool. The second retented or the acid insoluble, scientists have found thousands of organic compounds in the acid soluble pool. Organic compound in acid soluble, inorganic in retented. Inorganic in retented. Trichloroacetic acid. In higher classes, you will learn about how to analyze a living tissue sample and identify particular organic compound. It will suffice to say here that one extracts the compounds, then subject to the extract to various separation techniques till one has a separate compound. Analytical techniques. First two has elemental analysis, chemical into analytical. Analytical techniques when applied to a compound give us an idea of molecular formula. Analytical technique, molecular formula that molecular formula and probable structure of that compound and probable structure of that compound and probable structure of that compound. Probable structure of that compound, probable structure of that compound, probable structure of that compound. Analytical gives us the formula. Analytical gives us the formula. In higher classes, we will learn about how to analyze a living tissue sample and identify a particular organic compound. It will suffice to say here that one extracts the compound and subjects to extract to various separation techniques till one has separated a compound from all other compounds. In other words, one isolates and purifies a compound. Analytical techniques gives us to find the formula. When applied to a compound, give us an idea of the molecular formula and probable structure of the compound. Analytical technique. First two is elemental analysis, next to chemical, next to analytical process. Chemical, elemental, chemical, or analytical. Elemental, chemical, or analytical. Elemental, chemical, or elemental, chemical, or NEET. Elemental, chemical, or NEET. Elemental, chemical, or elemental, chemical, or analytical. All carbon compounds. All the carbon compounds that we get from living tissue are called biomolecules. However, living tissues have also got inorganic elements and compounds in them. How do we know this? A slightly different but destructive experiment has been done. One with inorganic amount of living tissue, say a leaf or liver, and this is called weight, and dry it. All the water evaporates, the remaining metal gives us the dry weight. Now if the tissue is fully burned, all the organic carbon compounds are oxidized to gases from CO2 and water vapor are removed. What is remaining is S. The S contains inorganic elements like calcium, magnesium, etc. Inorganic compounds are like sulfate and phosphate are also found in acid soluble pool. Sulfate and phosphate are also seen in acid soluble fraction. Sulfate and phosphate are seen in acid soluble fraction. Sulfate and phosphate are seen in acid soluble one with a small amount of living tissue, say a leaf or liver. This is called weight, and dry it. All the water evaporates, the remaining metal gives us a weight. Now if the tissue is fully burned, all the carbon compounds are oxidized to gaseous form, CO2, water vapor, and are removed. What is remaining is called as. This S contains inorganic element like calcium, magnesium, etc. Inorganic compounds like sulfate and phosphate, etc. are also seen in acid soluble fraction. 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 Acid soluble fraction. Therefore, elemental analysis gives us the elemental composition of a living tissue in form of hydrogen, oxygen, carbon, etc. While analysis of compound gives us an idea of kind of organic and inorganic constituent. To give an analysis of compound. Elemental analysis of compound. Elemental analysis of compound give us an idea kind and inorganic substituent present in the living tissue. From a chemistry point of view, one can identify functional group like aldehyde ketones, but from biological point of view, we shall classify them as amino acid, nucleotide base, fatty acid, etc. A comparison of elements present in non-living and living matter. A comparison of elements living in non-living and living matter. A comparison of elements living in non-living and non-living. Hydrogen more, carbon dioxide more, oxygen more, nitrogen more, sulfur more, sodium more बेसी है, sodium, calcium, magnesium, sodium, calcium, magnesium, और silicon, sodium, magnesium, calcium, sodium, calcium, magnesium, sodium, calcium, magnesium, 8 और बेसी, sodium, calcium, magnesium, 8 और बेसी, sodium, calcium, magnesium, 8 और बेसी, hydrogen, oxygen, hydrogen, carbon, oxygen, nitrogen, sulfur, hydrogen, carbon, oxygen, बेसी है. sodium plus prime sodium is heavy. Sila can name a mango hot cause it's nice. Or Sila can name mango hot cause it's nice. Or Sila can name mango hot cause it's nice. Or Sila can name mango hot cause it's nice. Or Sila can name mango hot cause it's nice. Or Sila can name mango hot cause it's nice. सबसे कम नाइट्रोजन और हेरियत सबसे नेग्लिजिबल इज सिलिकॉन. सबसे कम नाइट्रोजन सिलिकॉन सोडियम मैग्नीशियम कैल्शियम एंड सिलिकॉन सोडियम कैल्शियम मैग्नीशियम एंड सिलिकॉन सोडियम कैल्शियम मैग्नीशियम एंड सिलिकॉन. ऑक्सीजन दुईटारे सबसे बेसी बाट हेरी ओइ सिला कैन नेम मैंगो सेक्सी cause is nice. ओइ सिला कैन नेम मैंगो hot cause is nice. Or Sila can name mango hot cause is nice. 1 2 3 4 5 6 7 8 9. Or Sila can name mango hot cause is nice. Or Sila can name mango hot cause is nice. Or Sila can name mango hot cause is nice. Or Sila can name mango hot cause is nice. আৰু এইটো Or Sainika can never MGC. Sainika can never name. Sainika can never. Or Sainika never can hold sexy name MGC. 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 Or Sila can name mango hot cause is nice. Or Sila can name mango hot cause is nice. Or Sainika never can name sexy, never can hold this sexy name MGC. Never can hold 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 sexy name MGC. Or Sila can never name mango hot cause is nice. Or Sainika never can hold sexy name MGC. Or Sainika can never hold sexy name MGC. Or Sainika never can hold sexy name MGC. Or Sainika can never hold sexy name MGC. Sulfate and phosphate are also found in the acid soluble pool. Sulfate and phosphate are inorganic substances, but they are found. Sulfate and phosphate are inorganic compounds are also found in acid soluble. Therefore, elemental analysis gives us the elemental composition of living tissue in the form of hydrogen, oxygen, chlorine, etc. While analysis of compound or elemental chemical analysis or analysis of compound analytical give us the analytical techniques. Analytical techniques are way to cover deuterium is substitute glycine, methyl alanine, hydroxine, methyl serine. Acid soluble fraction. Therefore, elemental analysis gives rise to elemental composition. Elemental analysis gives rise to elemental composition. Therefore, elemental analysis gives rise to inorganic substance. And next we will say amino acid. Okay, first we will say amino acids. Primary and secondary metabolites. The most exciting aspects of chemistry deals with isolating thousands of compounds, small, big, from living organisms, determining their structure and if possible synthesizing them. If one were to make a list of biomolecules, such a list would have thousands of organic compounds including amino acids, sugars, etc. For that reason are given, we can call all these molecules as metabolites. In animal tissues, one notices the presence of all such categories of these are called primary metabolites. However, when one analyzes plant, fungal or microbial cell, there are see thousands of compounds other than this called primary metabolites. Example: alkaloids, flavonoids, rubber, essential oils, antibiotics, color pigments, scents, gums, spices. These are called secondary metabolites. While primary metabolites have identifiable function, play known roles in normal physiological processes, we do not at the moment understand the role of function of all the secondary metabolites in the host organism. However, many of them are useful to human welfare. Example: rubber, drugs, spices, scents, and pigments. Some secondary metabolites have ecological importance. In later chapter, you will learn more about this. Ecological importance of the secondary metabolites. So, kiki hoy alkaloids, flavonoids, scents, gums, spices, colored pigments, rubber, drugs, essential oils. Pigments are carotenoids and anthocyanins. Pigments are carotenoids and anthocyanins. Carotenoids and anthocyanins. Carotenoids and anthocyanin. 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 Alkaloids to হৈছে morphine, codeine. Morphine and codeine. Alkaloids to হৈছে morphine আৰু codeine. Alkaloids, morphine আৰু codeine. First to কি হৈছে carotenoids আৰু next to হৈছে anthocyanin. Carotenoids and anthocyanin. Pigments. Carotenoids. Anthocyanins. Carotenoids and anthocyanins. Carotenoids and anthocyanins. Carotenoids and anthocyanins. Pigment is carotenoids and anthocyanins. Carotenoids and anthocyanins. Next is alkaloids. Alkaloids का example की है. Alkaloids का example है. Alkaloids का example is morphine and codeine. Alkaloids, morphine and codeine. Alkaloids, morphine and codeine. Pigments, carotenoids আৰু anthocyanins. Carotenoids and anthocyanins. Alkaloids, morphine আৰু codeine. Terpenoids, monotrypsins আৰু diterpenes. Terpenoids. Morphine আৰু codeine. এইটো কি আছিলে carotenoids আৰু anthocyanins. Carotenoids and anthocyanins. Terpenoids টো হৈছে monoterpenes আৰু diterpenes. হয় নেকি? I don't know. Monoterpenoids, pigments to carotenoids আৰু anthocyanins, alkaloids is codeine and morphine, terpenoids is monoterpenes আৰু diethylamines, essential oils, lemongrass oil, toxin, everyone is okay. Why নেকি? Toxin, everyone আৰু ricin. Secondly, everyone ricin. कोई तो मिला था मुझे ऐसा लगता था जैसे सारी अदाएं सारी हवाएं मंगे धड़क रहा है दिल. lectins toxin everyone আৰু ricin toxin everyone আৰু lectins concanavalin lectins drugs vinblastine আৰু curcumin. Polymeric substance rubber comes in cellulose polymeric substance rubber comes in cellulose polymeric substance rubber comes in cellulose 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 rubber comes in cellulose. Pigments হ'ব carotenoids আৰু anthocyanins, alkaloids morphine আৰু codeine, terpenoids monoterpenes আৰু diethylamines, essential oil, lemongrass oil, toxin, everyone আৰু ricin, lectins concanavalin, drugs হৈছে curcumin আৰু vinblastine আৰু curcumin VC vinblastine আৰু curcumin RGC KMC धड़क रहा है दिल जाओ तो मेरा ना 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 AC MC MD LGO AR CA VC RGC VC and RGC oil Sila can never name mango hot for 6 nights. Sila can 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 name mango hot for 6 nights. Oceanica can never hold sexy name MGC. Sila can never hold sexy name MGC. Sodium, magnesium, silicon, sodium, calcium, magnesium, and silicon. 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 Pigments, carotenoids, anthocyanins, alkaloids is morphine and codeine. Terpenoids is monoterpenes or diterpenes, essential oil, lemongrass oil. Toxin is toxins, lectins, concovalent A. Drugs to হৈছে vinblastine আৰু curcumin. Polymeric substance to হৈছে RGC. Rubber comes in cellulose. Alkaloids কি কয় toxin. Every now racing air. Every now racing. 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 The most exciting aspect of chemistry deals with isolating thousands of compounds, small and big, from living organisms, determining their structure and, if possible, synthesizing them. If one were to make a list of biomolecules, such a list would contain thousands of organic compounds, including amino acids, sugar, etc. For reasons that are given in 9.10, we can call these biomolecules as metabolites. In animal tissue, one notices the presence of all such categories of compounds shown in 9.1. These are called primary metabolites. However, when one analyzes plant, fungal or microbial cell, they are primarily secondary metabolites. Fungal or microbial cell, one has thousands of compounds. Pigments, carotenoids and anthocyanins, alkaloids, morphine or codeine, terpenoids, monoterpene, lemongrass or toxin, epinaroricin, lectins to হৈছে concovalin I, drugs to হৈছে vinblastine আৰু vinblastine and vinblastine আৰু curcumin, polymeric substance, rubber, cellulose আৰু gumsin cellulose, rubber, 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 gumsin cellulose. Next to was biomacromolecules. There is one feature common to all compounds found in the acid soluble pool. Acid soluble pool are 8000 kg. They have molecular weight ranging from 18 to 800 Dalton, 18 to 800 Dalton, 18 to 800 Dalton, 18 to 800 Dalton, 18 to 800 Dalton. Dalton approximately. The acid insoluble fraction has only 4 types of organic compound: protein, nucleic acid, polysaccharide or lipids. These classes of compound, with exception of lipid, have molecular weights in the range of 10,000 Daltons and above. For this very reason, biomolecules, that is chemical compounds found in living organisms, are of two types. One, those which have molecular weight less than 1000 Dalton and are usually referred to as micromolecules or simply biomolecules, while those which are found in acid insoluble fraction are biomacromolecules except lipid. The molecules in insoluble fraction, with the exception of lipid, are polymeric substance. Then why do lipids whose molecular weights do not exceed 800 Dalton come under acid insoluble fraction, that is macromolecule? Lipids are indeed small molecular weight compounds and are present only in not only as such, but with two structure like cell membrane, cell membrane and other membrane, cell membrane and other lipids, cell membrane and other membrane form lipids, cell membrane and other membrane. The molecule in the insoluble fraction, with exception of lipids, are polymeric substance. Then by two, lipids whose molecular weight exceeds 800 Dalton come under acid insoluble fraction, that is macromolecule fraction. Lipids are indeed small molecular weight compounds and are present not only as such but also arranged in structures like cell membrane and membrane and other membrane. The grinded tissue where disrupting the cell membrane and other are broken into pieces which are not water soluble. Therefore, these membrane fragments is a vesicle gas added along with acid insoluble, and hence in the macromolecules are strictly biomacromolecules. The molecules in the acid insoluble, with the exception of polymeric substance, whose molecular acid insoluble fraction, that is lipids, small molecular weight compound present not only as such but arranged in structures like cell membrane. It is not easily enough video to maintain such meaning as now. toxin toxin. It is not receiving enough video to maintain smooth movement as such way. Status poor. Acid insoluble lipids are indeed small molecular weight compounds and are present not only as such. Lipids are indeed small molecular weight compounds and are present not only as such but present in the cell membrane or kiba. When we grind a tissue, we are disrupting the cell structure. Cell membrane and membranes are broken into pieces and form vesicles which are not water soluble. Therefore, these membrane fragments in the form of vesicle get separated along with acid insoluble pool, and hence in the out of the following elements which is present in least in human brain: nitrogen 1C, 1 second, mark the mismatch. Toxin is incorrect. Stress alkenoids, lectin, carcinogen is one of the alkenoids. Protein are required to pigments as alkenoids. Protein 4 to transfer carcinogen to 3. Which of the following? Which compound form 3% of the cellular mass? 3 is heavy carbohydrates. 3 2. 4. Which of the fat insoluble vitamin is involved in? It is a fat. Which fat soluble vitamins is involved in etc. I don't know. Among the energy values of nutrients, 9.3 calories is that of fats. The fats are the calories in fats. 1 fats equal 5, 1 fats to 100. 2. Sugars and amino acids are primary metabolites, secondary metabolites, feedstock and hormones. Obviously primary metabolites 6 1. Amino acid. Which of the following is plant toxin? Toxin is radiation, carcinogen is drugs, morphine is alkaloids, concovalin is lectin. 7 2. The living matter is mainly composed of carbon, nitrogen, sulfur and oxygen. Carbon, hydrogen 3. Select the incorrect statement from the following. Elemental analysis of living tissue gives elemental composition of living tissue. Correct. Analysis of chemical compound of living tissue gives us an idea of organic and inorganic substituent. Correct. Weight of small amount of living fresh tissue is known as weight. Acid soluble pool contains lipids, nucleic acid and heavy. 9 4. 10. The biomolecules which is less than dash delta is referred to as biomicromolecules. Less than 8. 10,000. 10 4. 1 3. Select the incorrect matching for the following percentage. Water 70 and 90% correct, proteins 10 to 15% correct, carbohydrates is 2%, nucleic acid 5 to 7%, 11, 3. Plants produce an enormous diversity of substances that have no apparent roles in growth and development process and are classified under the heading of secondary metabolites. 12 to 13. Which one of the following is secondary metabolite? Amino acid, fibroids, and antibiotics. 13 3. Yes. 14. Which one of the following statement is incorrect? Which one of the following statement is incorrect? Primary metabolites have indefinable functions. Some secondary metabolites have ecological importance. Secondary metabolites are byproducts and pigments are useful for human welfare. Secondary metabolites are not found in fungal. 14 4. 15. Which is not of secondary metabolites? Fibroids, antibiotics, carotenoid acids, enzymes, gums and spices, amino acid, and nucleic acid. Which one of the following statement is incorrect? Which of the following is incorrect? All the elements present in a sample of art grass are also present in sample correct. Relative abundance of carbohydrate with respect to higher energy limits and correct. Living organisms have more nitrogen and oxygen per unit mass than animate living organisms have more. 16 3. The correct order of the chemical composition of the living tissues cells in the perfect of the total cellular mass is एकदम first water, তাৰপিছত proteins, তাৰপিছত nucleic acid, তাৰপিছত carbohydrates, তাৰপিছত lipids, তাৰপিছত ions. 17 2. 17 2 correct. Which of the following statement concerning polymer is not true? Polymers. Concerning polymers not true. Polymers Which of the following element is abundantly found in living organisms when compared to carbon and hydrogen, oxygen? But all of this. To analyze the chemical composition of living tissue, we solubilize ClCl3. The percentage of oxygen in human body is 65%. In the following 1 2 3, less percent of the cell mass is by ions. Ions would say from 1%. Select the correct matching of the percentage compound of the following: water 70-90%, proteins 10 to 50%, carbohydrate 2%, nucleic acid 5 to 7%, and 3. biomolecules that is formed inside the living cells by some metabolic activities are called as biomolecules. 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 Any molecules that is formed inside the living, any molecule that is formed inside the living cell by doing some metabolic activities or processes are called biomolecules. Or processes are called biomolecules. Any molecule that is formed inside the living cells by doing some metabolic activities are called biomolecules. Is the outcome of metabolic process, hence they are also known as metabolites. There are two types of metabolites on the basis of necessity or influence of life. Also plays a key role in the growth and development and reproduction. No such role formed during the starting of growth, formed during the end of growth phase. Biomolecules on the basis of they play a common role, mostly found in plants, fungal and microbial cells. Primary metabolite in normal physiological processes such as photosynthesis, respiration, protect, lipid metabolism, etc. In normal physiological processes such as photosynthesis, respiration, protein and lipid metabolism, etc. In normal physiological processes such as photosynthesis, respiration, protein, etc. Example: amino acid, nucleotide, acidic acid, lactic acid, vitamins, etc. Rubber, gum, cellulose, carotenoids, morphine, erythromycin, etc. Biomolecules are of two types. First two was a biomacromolecules. Macromolecules or biomacromolecules. Cuboidal cells, Gibbs junction are made for transmembrane protein. They are made up of intercytoplasmic connection. Each of the protein is made up of 6 layers. Next to molecular weight less than 1000. More than 1000. These molecules can pass through the Gibbs junction. These cannot pass through the Gibbs junction. Simple structure, deficient complex structure, acid soluble as well as water soluble fraction, except lipid. They are acid insoluble and water insoluble fraction. Nucleic acid, protein, carbohydrates and polysaccharides, amino acids, sugar, nucleotides, lipids. They are organic biomolecules, water, minerals, inorganic and heavy. Next we say carbohydrates. Carbohydrates are non-metabolic proteins. Proteins are polypeptide. 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 They are linear chains of amino acid linked by peptide bond. They are linear chains of. They are linear chains. They are linear chains of amino acid linked by peptide bond. Linear chains. They are linear chains. Proteins are polypeptide. Polypeptide. Proteins are polypeptide. They are linear chains of amino acid linked by. They are linear chains of amino. Proteins are polypeptide. They are linear chains. Proteins are polypeptide. They are linear chains of amino acid linked by peptide bond. Linear chains of amino acid linked by peptide bond. They are linear chains. Proteins are polypeptide. Proteins are polypeptide. They are linear chain of amino acid linked by peptide bond. Linear chains of amino acid linked by peptide bond, as shown in figure 9.3. Proteins are polypeptide. Proteins are polypeptide. They are linear chains of amino acid. Linear chains of amino acid. Proteins are polypeptide. 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 Proteins are polypeptides. They are linear chains of amino acid linked by peptide bond, as shown in figure 9.3. Each protein is a polymer of amino acid. Each protein is a polymer of amino acid. As there are 20 types of amino acid, example adenine, cysteine, proline, tryptophan, lysine, etc. A protein is a heteropolymer and not a homopolymer. Not a homopolymer, heteropolymer, not a homopolymer. Same name like. As there are 20 proteins from proteins, not there homopolymer, not homopolymer. A homopolymer has only one type of monomer repeating in n numbers. A homopolymer has only one number monomer repeating n numbers. This information about the amino acid content is important as later. This information about the amino acid content is important as later in a nutrition lesson. You will learn that certain amino acids are essential for our health. They have to be supplied through our diet. Hence, dietary proteins are source of essential amino acid. These information are important. You will learn certain amino acids are essential for our health. They have to be supplied through our diet. Hence, dietary proteins are source of essential amino acid. Therefore, amino acid can be essential or non-essential. Essential or non-essential. The latter are those which our body can make while we get essential amino acids through our diet and food. Proteins carry out many functions in living organisms. Some transport nutrients across the cell membrane. Functions in cell membrane. Some transport nutrients across the cell membrane. Some fight infection organisms. Some are hormones. Some are enzymes, etc. Some are hormones, enzymes, etc. Function যেটা তিনটা মেনশন করা হয়েছে, তিনটা ফাংশন মেনশন করা হয়েছে। ফার্স্ট টু হয়েছে সাম অ্যাক্ট এজ এনজাইমস, অ্যাক্ট এজ হরমোনস, সাম ফাইট ইনফেকশাস ডিজিজ অ্যান্ড সাম হেল্প। Homopolymer to heteropolymer. Proteins and polypeptides share linear chains of amino acid by peptide bond, as shown in each polypeptide heteropolymer. A homopolymer has only one monomer repeating n numbers. This information about the amino acid content is important as later in nutrition you will learn about certain amino acids essential for our diet. They have been supplied for our diet, hence dietary proteins are source of essential amino acid sources of it. Therefore, amino acid which our body can make while acids are proteins carry out different functions. First, as hormones, enzymes carry out substance from one cell membrane to another. Some transport the nutrients across cell membrane, some fight infection. Some are hormones, some are enzymes. 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 কি ফাংচন আছে চাৰিটা. এটা হৈছে ফাইট ডিজিজ, এনজাইমছ, ফাইট ডিজিজ, hormones, enzymes, and then transport nutrients in cell and some proteins and their functions. Collagen, intercellular ground substance. Okay, collagen to jano intercellular ground substance. What is collagen? It is intercellular ground substance. Trypsin is an enzyme. Insulin is an hormone. Antibody fights infectious as a receptor. Sensory receptacle, smell, taste hormone. GLUT4 enables glucose transport into the cell. 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 Collagen, intercellular ground substance. Trypsin is a insulin is a hormone. Trypsin is an enzyme. Trypsin is an enzyme. Insulin hormone, antibody fight infectious disease receptacles, sensory receptacles, enables glucose and transport into cell. Collagen is the most abundant protein in animal world. Collagen and is most prominent protein in the whole biosphere. Collagen is the most abundant protein in animal world. Most abundant protein. Collagen is the most abundant protein in the animal world. And ribulose, biphosphate, carboxylase, oxygen. Ribulose, biphosphate, carboxylase, oxygenase. Rubisco is the most abundant protein in the whole of biosphere. 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 Proteins are polypeptides. They are linear chains of amino acid linked by peptide bond. Astronomic figure is protein is a polymer of amino acid. 20 types of terminal homopolymer, heteropolymer is only one type of monomer. This information about the amino acid is important as later in your nutrition lesson you will learn that certain amino acids are essential for our health and they have been supplied for our diet. Hence, dietary proteins are sources of essential amino acid. Hence, dietary proteins are sources of essential amino acid. Therefore, amino acid can be essential for later are those which are proteins carry out many functions. First is fight infection. Secondly is transport of nutrients from one cell membrane to another. Terms of enzymes, hormone, collagen, intercellular ground substance, trypsin, insulin hormone, antibody fight infectious agent, receptors, sensory receptors, smell, taste, and hormone receptor. GLUT4 enables glucose transport into the cell. GLUT4 enables glucose transport into the cell. 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 RUBISCO. is derived from a Greek word which meant holding fast. Proteins derived from a which meant holding fast. It was discovered by scientist C.L. Marvin under were investigating the ovulating substance in milk from egg. Protein was formed by J.J. Proteins are large molecules with molecular weight 5,000 to 1,000 proteins are considered to be body's building block of our body. Proteins are considered to be building blocks of our body. The building block of our body. Building block of our body. What is the building block of our body? Proteins. Proteins are known as the building block of our body. Proteins are known as for cellular protein differentiation. For cellular protein differentiation. For cellular protein differentiation. Proteins. Amino acids are building blocks of protein. तेरे नाल गदा पास हुआ दिल दीवाना तेरे साथ building blocks of our body building block of our body for cellular growth and differentiation, 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 for cellular growth. Amino acids are organic compounds. Amino acids are organic compounds. Organic compounds containing amino group and acidic group and substitute group on the that is on the alpha carbon. Hence they are called alpha amino acid. Hence they are called alpha amino acid. They are substituent methane. Methanol CH3 that is vegetable. That R. That NH2 or that COH. Therefore, they are four occupying four valency. These are hydrogen. First to is hydrogen. Next to is a carboxylic acid, or next to is a amino acid, designated as R group and a variable R group. Based on the nature of R group, there are many amino acids. However, those occurring proteins are only of 20 types. 20 types of amino acids are found. First to is the R group. These are proteinaceous amino. The R group in this proteinaceous amino acid could be hydrogen. Amino acid is called glycine. A methyl group alanine and hydroxymethyl is serine. There are of 20 types. First to is অকল H থাকিলে হলে glycine. Amino acid অকল H লাগি থাকিলে glycine. তাৰপিছত CH methane লাগি থাকিলে alanine আৰু এইটো serine. Alanine আৰু serine. Alanine আৰু serine. Alanine আৰু serine. Alanine and serine. Alanine and serine. Alanine and serine. Alanine and serine, 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 alanine and serine. Now first to see so it's a simple NS is the about glycine. Glycine, alanine are serine. A substituent glycine, methyl substituent alanine, hydroxy substituent serine, and hydroxy substituent in serine. The chemical and physical properties of amino acids are essential. The chemical and physical properties are essentially of amino, carboxyl, and R groups. Based on the number of amino groups and carboxyl group, there are acidic. Example: glutamic acid. Basic example: lysine. Neutral example: valine amino acids. Similarly, there are aromatic: tryptophane, phenylalanine, and tryptophan. A particular property of amino acid is ionizable of NH2 and COH group. Hence, in solution of different pH, the structure of amino acid changes. B is called deuter ion. B is called deuter ion. B is called deuter ion. For acidic to as a glutamic. Neutral is valine, into lipsin is basic, aromatic is tyrosine, phenylalanine and tryptophan, 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 tyrosine, phenylalanine and tryptophan. Amino acids are organic compound. An amino group and acidic group are substituent on the same atom, that is alpha carbon. Hence they are called alpha amino acid. They are substituent methane. The four substituent group occupying the four valence position. These are of hydrogen carboxyl amino group. Very occurring proteins, only of 20 types. The R group is in this proteinaceous amino acid could be a hydrogen amino acid is called glycine, a methyl group aniline or serine. The amino acid is called glycine, a methyl group is called alanine, hydroxyl methyl is called serine, amino group is glycine, a methyl group is alanine, or itu hydroxy methyl is serine, etc. There are 20 types. The chemical and physical properties of essential of amino acid carboxylic R group based on the number of atoms, number of amino groups in there. These are first to hoise acidic to hole heri acidic is glutamic acid aru itu lysine, neutral is valine. Similarly there are aromatic amino acid tyrosine, phenylalanine aru tryptophan. Tyrosine, phenylalanine aru tryptophan. A particular property is ionizable nature of, hence in solution of iron it shows deuterion. जाने जाना classification of amino acid: protein amino acid, non-protein amino acid. Okay, takes part in protein synthesis and forms important proteins. Effect of physiological processes such as formation of enzymes, hormone, etc. They hold some biological importance as well as helpful in doing several physiological processes, but do not take part in protein synthesis or select glycine, alanine, serine, glutamic acid, lysine, tryptophan, tyrosine, aru phenylalanine, valine. Neutral is valine. The reason for there are 20 unmodified amino acid is the alkyl group. Amino acid also can be classified into acid, basic, or neutral amino acid depending upon the acidic number of amino acid carboxyl group present in them. So the basic acid acid monoxide. glutamic acid, niacin, L-trypsin, quercetin, serine, adenine, serine, glycine, adenine, serine. shall cannot be synthesized by organism in body inner obtained from plain space food. They are also they can also be obtained from eggs, peanuts, sesame seeds, soya, fish, and leafy vegetables. Laboratory except of environment. Tryptophan is the most complex. Tryptophan is the most complex. Tryptophan is the most complex amino acid. Tryptophan is the most complex amino acid. Tryptophan is the most complex amino acid. Tryptophan is the most complex. Glycine is the simplest. All amino acids are laboratory except this is glycine. Except glycine, non-rotated. Except glycine, this is non-rotated. Except glycine, this is not rotated. Special points glycine. Glycine is the simplest amino acid. 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 Amino acids are usually colorless. These are water-soluble, high-melting solids and behave as salts rather than simple amides or carboxylic acid. Their behavior is slightly inclined to acidic pH, but they are not completely an acid. Behaves as one. Their behavior is due to presence of both acidic as well as basic. Due to concept being in aqueous solution, basic substance always have the tendency to accept H plus ion, whereas carboxylic group will lose one. Thus, only any zeta ion amino acid shows amphoteric behavior, where a particular amino acid behaves both as acid as well as base only when an amino acid is in aqueous solution. Thus, in free protoplasm or blood, amino acid occur in the form of an ion. Amino acid occur in the form of an ion. Aqueous medium. Being in aqueous solution, basic substance. Being in aqueous solution. Being in aqueous solution. Being in aqueous solution. Being in an aqueous solution, basic substance always have. Being in an aqueous solution, basic substance always have the tendency. Being in aqueous solution, being in an aqueous solution, basic substance always have the tendency to accept H plus, whereas carboxylic group will lose one. Thus, any zeta ion amino acids or amphoteric behavior of a particular amino acid. Thus, in the protoplasm, free protoplasm or blood, amino acid occur in the form of an ion. Amino acid occur in the form of an ion. Amino acid occur in the form of an ion. Amino acid occur in the form of an ion. Amino acids occur in the form of an ion. Amino acid occur in the form of an ion. Glycine is the simplest. Tryptophan is the most complex. Tryptophan is the most complex, simplest, most complex. All the amino acids are laboratory except glycine. This is non-rotative. Non-rotative exception. Non-rotative. Exception. Non-rotative. Exception. Non-rotative. Others are all rotative. Laboratory. Proteins form approximately 15% of the animal's protoplasm. Protoplasm from the frame of that protoplasm. Proteins are nitrogenous macromolecules. The nitrogenous content is around 16% structure of protein. You are on your own. You've always been this. Lipids are found in protoplasm. Lipids are generally water soluble. They are generally water insoluble. Lipids are generally water insoluble. They could be fatty acid. Fatty acids. A fatty acid has a carboxylic group attached to R group. RCOH. The R group could be methyl or ethyl or C2H5 or higher membrane like C2 group. For example, palmitic acid has 16 carbons including carboxyl atom. Arachidonic acid has 20 carbon atoms including 20 carbon including carboxylic group. Fatty acid could be saturated without double bond or unsaturated with one or more double bonds. Another simple liquid is glycerol, which is trihydroxypropane. Many lipids have both glycerol and fatty acids. Lipids are generally water insoluble. They could be simple fatty acid. And understand the water insoluble. Lipids are generally water insoluble. They could be simple fatty acid. A fatty acid has a carboxylic group except they could be simple fatty acid. A carboxyl acid has a acid group attached to R. Carboxyl COH. The R group may be methyl, ethyl, hydroxyethyl groups, or for example, palmitic acid has 16 carbon. Palmitic acid has 16 carbon, including carboxylic carbon. Palmitic acid has 16 carbons, including heavy. Arachidonic has 20 carbon, including carboxylic group. Fatty acid can be saturated or unsaturated, saturated single bond, unsaturated or double bond, saturated without double bond, unsaturated with one or more double bonds. Another simple liquid is glycerol, which is trihydroxypropane. Glycerol. Palmitic acid, arachidonic acid, arachidonic acid. Lipids are generally water soluble. Lipids are generally water soluble. They could be simple fatty acid. Here C is attached to R. তাৰপিছত এটা R group contain হেৰি first one আছে palmitic acid 16 carbons palmitic acid is 16 carbons palmitic acid is 16 carbons palmitic acid is 16 arachidonic to has a 20 arachidonic 20 fatty acid could be saturated with double bonds or inside glycerol, which is trihydroxypropane. Many lipids have both glycerol and fatty acid. Another simple lipid is glycerol and fatty acid. Hence, here the fatty acids are found esterified with glycerol. They can be then monoglycerides